Okay, today we're doing something a little different. We're not just going to cover a topic, we're going to crack the code of a real AQA GCSE Physics exam question. We are going to take it apart, piece by piece, using the official mark scheme as our guide to see exactly how you win every single mark. So let's just dive right in.
So here's the big question, right? You can know your physics inside and out. You can know all the formulas, all the concepts, but there's this gap, isn't there? The gap between knowing the stuff and actually writing an answer that scores you full marks. Well, today, we're going to close that gap for good. You're going to see exactly what an examiner is looking for. So, here's our game plan. We'll start by cracking question 3, grabbing those foundational knowledge marks first. Then we'll get into decoding redshift, nail the big calculation, and finally, I'll show you how to write that perfect level 2 answer. By the end of this, you'll be looking at the mark scheme like it's your personal blueprint for success. All right. First up, the foundational knowledge questions. Now, these are usually about remembering a key fact or just pulling some data from a table. Honestly, they're designed to be your confidence boosters, the easy wins to get you started. And you absolutely do not want to leave these marks on the table. Okay, so question 3.1 asks for 3 other types of objects in our solar system besides the sun. And look at this. The official mark scheme gives you a whole buffet of options. You only need to name 3, but you could have said planets, moons, asteroids, comets, any of these. It just goes to show, for these recall questions, there's often more than one right answer.
Next, question 3.2. You're given a table with different stars and their masses, and you have to pick the one most likely to become a black hole. The mark scheme is crystal clear. The answer is Betelgeuse. And why? Well, you probably guessed it, it's all about mass. Betelgeuse is the heavyweight in that table by a long shot. Easy mark, just for reading the data correctly.
And rounding out this section, question 3.3 is a simple unit conversion. It gives you a distance in gigametres and just asks you to switch it to meters. The correct answer, right there on the screen, is 1.1 times 10 to the power of 17 meters. One tick box, one more mark in the bag. Just like that, we've already banked 5 marks. See, we're off to a great start. So let's see how the question starts to build on that foundation. We're moving into the more analytical stuff now, decoding redshift. This one's worth 3 marks, and it's all about interpreting what you see. And this is the picture they give you. This is your evidence. You've got the light spectrum from our sun as a baseline, and then you have the light from 2 faraway galaxies, A and B. The whole question is about what this tells you about how they're moving. Just look closely at how those dark lines have shifted to the right for both galaxies. That's the key. So how do you turn that observation into 3 marks? Here it is, word for word from the mark scheme. Mark number 1, you state that both galaxies show redshift, which means they're both moving away from us. Boom. Mark number 2, you compare them. You point out that galaxy A's lines have shifted more than B's. And for the third and final mark, you connect the dots. A bigger redshift means it's moving away faster, so A is faster than B. It's a perfect chain of logic. 1, 2, 3. All right, it's calculation time. I know these can look a little scary, but here's the great thing. You get marks for every single correct step along the way. This is a 4-mark question, so let's break down exactly where each of those 4 marks comes from. Now get this. The very first mark is yours before you even touch the main equation. The distance is given in kilometers, right? But the speed of light is in meters per second. So step 1, you just convert the units. Change kilometers to meters, write it down, and you've already scored your first point. Simple as that. The second mark is just for putting the numbers in the right places. It's called substitution. You take your new distance in meters, you take the speed of light, and you plug them into the equation. You just have to show the examiner you know which number goes where. That's it. Mark number 2 is yours.
Now this is amazing. You get a whole mark just for rearranging the equation. Before you even grab your calculator, just by showing that you know you need to divide the distance by the speed to find the time, t, you get the 3rd mark. This right here is why showing your work is absolutely critical. And finally, the 4th mark is for the correct answer. Now you can pick up your calculator, do the division, and you get 1.2 times 10 to the power of 9 seconds. Write that down, and you've nailed it. 4 super clear steps, 4 marks in the bag. It all makes perfect sense. Okay, here we go, the grand finale of question 3. This is the 4-mark extended response, the big one. It asks you to describe how stars create all the other naturally occurring elements. Now, these longer questions are marked in a totally different way, so let's take a look.
So, this is super important. For a question like this, the examiner isn't just ticking off a checklist. They read your whole answer and then decide what level it's at. A level 1 answer might just have a few random correct facts. But to get to a top level 2 answer for 3 or 4 marks, you need to tell a story. Your facts have to be relevant, detailed, and in a logical order.
So how do you write that perfect, logical story? Well, the mark scheme actually gives you this indicative content. Think of it like the examiner's secret checklist of ideas. You'd want to talk about fusion needing high temperatures, how hydrogen fuses into helium, then what happens when the hydrogen runs out, how heavier elements are made, all the way up to iron. And for the really heavy stuff, you absolutely have to mention that massive stars go supernova. Weaving these points together is what gets you those top marks.
So there you have it. We've just walked through an entire 16-mark question, from the first easy point to the final complex paragraph. So what's the big idea here? What's the main takeaway from doing all this?
It all comes down to this. The mark scheme isn't some secret document for teachers. It's your blueprint. It is the guide to your answer. It shows you exactly where the marks are, what level of detail they want, and the logical steps they're looking for. Knowing your physics gets you in the door, but understanding the mark scheme is what lets you walk out with every single point you deserve. You now have a totally new way to look at exam questions. You can see them through the examiner's eyes. You know how the marks are built up, from simple facts to killer arguments. So really, the only question left is, now that you have the blueprint, which question are you going to go and master next?